Good evening, ladies and gentlemen. Tonight in episode 7 we will continue on with our heavy-duty knurling toolkit build series. Tonight we are going to concern ourselves with the spring collars, as well as assembling our almost complete knurling tool. Let's have a look at the component identification page. Here's our component identification page. You can see here the spring collars called out as number 7. They form part of the tensioning rod system. The tensioning knob controls the tension, controls the compression on the compression spring, and our spring collars prevent that spring from getting jammed up inside between the arm assemblies. It basically manages the spring. Let's go to the actual part page of the drawings for the spring collars. Okay, here we have the spring collar part drawing. Sheet number 12 of 16. There's a fair bit going on in this part, nothing too serious. Our stock is from 5/8 brass, and our outside dimension is 9/16, so we have some work to do there right off the hop. We have to reduce our overall dimension of the OD of the stock down to 9/16. I think I will do what I call a double ender on this part. I'll use my collet chuck, and the stock comes as one piece. So we'll do the OD, then we'll do this smaller diameter area on both ends of the stock. We'll flip our stock in the chuck and do both ends. And we'll ream the entire stock. Only then will we split our stock and create this larger bore. Okay, let's have a look at the order of operations. Okay, kind of had a rethink about how I'm going to do the order of operations on these two spring collars. What we'll do is take our entire piece of stock, we'll face off both ends, then we'll turn this .370 diameter on each end. We'll leave the stock at full width until we get that done. Then we will drill and ream the entire stock, this 5/16. Then we will take our stock, part it into two pieces, and we'll trim the two pieces of stock to 19/32. And lastly, we will create this pocket in each part. Okay. Let's head over to the lathe. Okay, here we are at the lathe. We have our collet chuck set up. Here's our stock. We're going to do the old double-ended trick. We're going to start machining both spring collars. We need two. We're going to start machining them both out of the same piece of stock. Our first operation is to create this .370 diameter for a length of 7/16. .370 or 9.4 millimeters. We'll face this end of the work. There we go. Now I'm not going to move my carriage. I'm going to bring in my magnetic back dial indicator. I'm going to use up almost all my travel here because we got to go 13:30 seconds. And bring in my stop, snug it up a little bit. 13:30 seconds is 0.406 of an inch, or 11.2 millimeters. 0.406 of an inch. 100, 200, 300, 400, 06. I'm going to lock my stop there. Remove my dial indicator. We're done with that for now. And so we're going to take this stock down to 0.370. Just touched off. I'll set my dial to 0. Going to advance my carriage 25 thousandths. Reset to 0. And make a pass using power feed. There we go, up against the stop. Okay, I've taken a measurement with our dial set at, crossfeed dial set at 0. I've done the math and we have 228 thousandths to take off the diameter. We'll start with 25 thousandths. Okay, 25 thousandths pass. Let's try 50. That's last pass. We are looking for 370, 369. Perfect. So now I'm just going to, I know where that is on my dial. So when we do the second half here, I can hit that number again easy. I just have to reset my stop for my carriage stop for that length. We're not in the same spot in the collet anymore, so we'll have to reset that for our length of 406. I'll bring you back when I've got this side done. Okay, so we have our two reduced diameter areas for our two spring collars. So we can check that off our operations list. Next thing we want to do is drill and ream all the way through this stock, 5/16 diameter. I'll get set up for that and bring you back. Alright, reaming 5/16, or if you're doing the metric version, 8 millimeters. We have a center drill in our tailstock chuck for starters. Then I have a drill bit, a 64th under our ream size, and finally the ream. Let's get started. This is a fairly deep hole. I don't want my chips to pack up in there and cause trouble, so I'm retracting often and cleaning out those chips. That was tedious. Okay, and finally our reamer. Slow that down a little bit. Drill and ream entire stock. Check. Next thing is to part our stock in half. I'll get set up for that and bring you back. Okay, I've marked the center line of the work. I have my parting tool squared up to the work. I will put us back to 460 RPM. Away we go. Piece of cake. We're really cruising along here now. Next, trim part to length. So we got to remove quite a bit of material here. There's a lot of excess brass there. We'll switch over to a 3/8 collet. Alright, our next step is to, despite what I said previously, our next step is to get this OD to where we want it. We want it at 9/16 diameter, or 0.562, or 14.4 millimeters. I'm going to advance my carriage, touch off, advance a further 20,000 depth of cut, set my dial to 0, take my cut, and then measure and see where we're at. One more time. I'm going to touch off, I'm going to advance a further 20 thousandths. I'm speaking of diameter on my lathe. When I set my dial to 20 thousandths, that's diameter. I'm going to advance another 20 thousandths, set my dial to 0, we'll make the cut, and then we will measure, see where we're at. Here goes. Zero on our dial has brought us to 0.602. Our project is our HDK spring collar. It features the OD on the spring collar. Size on the print says 0.562 or 14.4. Zero on our cross slide dial brought us to 602. We have another 40 to go. We'll do 2 passes at 20 thou. My almost new Mitutoyo calipers, 0.561. We were looking for 562, or thousandths under, which is just fine. So now we have that number 40 on our dial. We know that's where we were going to be. So this one, we don't even have to think about it. Forget about it. Sorry. Let's just double check what that came out to. Looking for 562. We have 558. That'll work. Okay. We can check that one off of our list. Trim to length. We're only supposed to have 3/16 in here. We got way too much material. I'm too generous with the brass and the kit. So I'm not sure what's the best way, if we just whack at it with our diamond tool holder or if I use my parting tool. This area here is not that thick right now, so I don't think we want to part this top part. So I'm just going to whack off a bunch of this and then we'll see where we're at. Whack gently. Okay, I think what I'll do is take this out of the chuck, mark it up with Sharpie, and scribe myself a line. Okay, I think you can make out where I've scribed a line on the part there. So now we'll just continue. I'm going to adjust the angle of my diamond tool holder. We'll use that whole leading edge of the tool. Carefully. Here goes. There we go, pleasantly uneventful. Okay, I'll mark up the second part and I'll bring you back. Okay, we've got our second one with the line marked on it. Here we go. We better get some slow-mo of this. Go. So there we go, we have our part trimmed to length. Now we need to create that cup where the spring sits. So it's a boring operation. I'll bring you back when we're set up. Okay, this is the feature we're working on. We're doing this cup where the spring sits. First thing we'll concern ourselves with is this 0.160 depth of cut. 0.160 or 4.1 millimeters. I have my boring bar up against the work. I have my stop just snug on the ways so it can't flop around, but is still movable. I have my magnetic back dial indicator set up against the carriage here. We'll just find 0, we'll get it nice and parallel, set it to 0. Move my tool off the work, advance 0.160. Lock my stop. There we go, we don't have to worry about that anymore. Our depth is set for this part. When we change parts, we'll have to, of course, reassess. This is the smallest boring bar I have, and it won't even start in the hole, so we have to cut our way in. We'll enlarge that hole a bit, and then we'll take a measurement. With my dial set on 0, we now have a bore of 0.337. I've done the math and we have 148 to take off the bore. That's see how he did. I give her a lick on the grinder. I think we were cutting brass that time. I'm going to give it another 10. I got too much deflection in my boring bar. There, that fits. Not crazy about it. Yes, now this it's big enough now that this carbide insert boring bar would work. I think that's what I'll do. We'll come back and revisit. I'll do this, I'll get the other one to this point. Then I'll bring you back. Okay, it wasn't pretty. You can be glad you missed it. But we have a nice fitting cup there now. I'm on this carbide insert boring bar. So now I still have my dial set 165. It worked out too. There's both of them cleaned up. Good. We'll take a little Scotch-Brite and get rid of the Sharpie and the sharp edges. That looks pretty awesome, actually. Clean this one up. There you have it, guys and girls. I'll bring you back and we'll wrap this one up. Alright, we have our 2 spring collars completed. We can check off our last item on the order of operations. We've created those bores for where the spring sits. So that's a wrap for this part of our knurling tool. There's our spring collars in position. The last part, we've got everything taken care of except the tensioning knob here. Tune in next episode and we will create that tensioning knob with that beautiful knurl on there. Thanks for watching, guys. Like and subscribe. There's a link in the description to where you can purchase your kit and other great kits down at the store. Thanks for watching. Take care. Be safe. We'll catch you next time. Thanks a lot.